So good morning. So we have completed already 4 weeks class. Now it is fifth week. So fifth week we'll try to discuss detail about heater treater, gun barrel, and other mechanism how to separate systems. We have already gone through your emulsion treating methodology, like you are using different what is emulsion, how it is creating, how it is how you are breaking the things. So that we have discussed. But actual mechanical equipment, how you are using and how you are separating things, we will discuss in this lecture. Okay. So basically week 5 and week 6 will be combined. So let's see topics one by one. Start with heater treater, and basic book will be like Arnold, Stewart, whatever book we are following, same book. And I found another book is there from Arnold and Stewart, same authors, emulsions and oil treating equipment. So I'll try to cover something from that area also. And if you want to get more information, you can go through like heater treater YouTube video is there, and many text also will be there in different web pages. So try so that you can go through those videos. So video will make more clear sometime, because in class when you are teaching will be going more mathematical fundamental aspect, where video will be giving some basic concept which using that one you can understand very easily. But for our class understanding we will be giving much more deeper, because we have to go from mathematics calculation. Okay, so video can give some outside some overview of things, but for detailed design and other part we have to go through the class. Okay. I hope there will be many other lectures also available. So just if you can find good lecture, you can watch that also. But for exam purpose, you have to follow our video records and whatever given in the book. Okay. So in previous lectures we have seen like two-phase, three-phase separators, right? And two-phase, like we are assuming 50%, almost 50% or more than or less gas, and liquid will be almost 50%. But if we assume three-phase, so gas, oil, water will be there, and in that case also we assume maybe 50% gas and oil plus water. That will be may not be 25-25, it may be different ratio also. Okay, so that way we calculate it, but we can calculate other ratios also. For example, gas will be 60%, liquid will be 40%, or vice versa. So in that case also we have seen some formula. You can see previous lectures and you can try to calculate. So instead of remembering direct formula, end formula, you try to remember the steps, how you are solving the problem, then it will be easier for you. Otherwise you have to remember lots of constants and other parameters which may be wrong, or maybe in exam I can give certain parameter which may not be directly related to your final formula, rather maybe steps. Okay, so you should try to remember the steps, how you are solving the problem. Okay, so that will be more important than giving final formula and getting result. Okay. And we have seen vertical separator also same way, like 50% field. Okay. So in this case we will try to see three-phase separation, how we are getting gas, oil, and how we are separating emulsion using heating method. Okay, heater treater means you are applying heat to increasing temperature. Okay, you are heating oil gas mixture, increasing temperature, that will change your viscosity. When viscosity changing, heavier particle will be settling quickly, lighter particle will be moving up. So separation rate will be quicker. So retention time will be lower. Okay, so finally you are trying to reduce retention time, so your system will be more compact and your process will be faster. Okay, more fluid will be flowing through the separator system. But if you are not giving heat, you can use other methods also. So in that case your separation retention time may be higher. Okay, and some particle may not be separated properly because heat will be lightweight molecules will be getting evaporated also, so you will be separating quickly. Okay. So to go through this chapter, actually you have to you have to get you have to recap the previous chapters, like emulsion treating theory we have already discussed actually. So why emulsion is getting created, how you are separating, and what are the chemicals you are using. So that theory also you have to go through. Okay, gravity separation already we are discussing. Gravity is because of gravitational force. Lighter particle will be falling slowly, but heavier particle will be falling quickly, and gas very light, so it will be moving up. Okay, so that theory already you know, but you can recap also. Coalescence, so different coalescing media will be there, and coalescing means like particle collision is there. So, particle collision means you are getting bigger particle. When bigger particle is there, settlement rate will be quicker. Okay. So, how fast you are settling, that will be deciding your separator size and different equipment sizing also. Okay. And you have seen this treating equipment like horizontal separator, vertical separator, and we will discuss something electrostatic treating system also. Electrostatic. So, using electricity, you can separate. That we already discussed, but we will go more elaborate in this chapter. Okay, so before we go through details of heater, two things we need to know. The dump valve, we are using this term. Okay, dump valve, or this is having different name also, like blow off valve. Okay, so many times if people are not writing dump valve instead of that one, they are writing blow off valve. So, you should not say, okay, so I do not know this one. Okay, so that is why you should know the different names also, alternative names. Different company will be using different names. Many times they will be patenting with certain name. Okay, so you should know all the alternative names. Compressor bypass valve. So, you are not using compressor, but they say compressor bypass valve, dump valve. Okay, so you are bypassing certain liquid so that you can control the pressure up to certain level. So, you are controlling pressure or you maintaining the liquid level. So, liquid level controller will be controlling the dump valve so that you can release liquid slowly. Okay, so you should know the names. Another will be relief valve. Relief valve or pressure relief valve. Okay, so when you are saying PRV, they say in short form, the relief valve or pressure relief valve, like safety valve used to control or limit the pressure in a system. Okay, for example, you have seen gas, your pressure cooker. Pressure cooker will have pressure relief valve, otherwise it will be completely unsafe. Okay, so your separator system also you will have that sort of valve. Like say dump valve is not working or suddenly pressure is going up, temperature is going up. So in that case, your pressure release valve must be working, so that it will be reducing pressure quickly and system will be safe. Okay, so heater treater, this term we have used several times. Okay, heater treater is the main function, heat crude oil. Okay, it may be water mixture also. Okay, crude oil and water mixture or only crude oil. Okay, you are heating. Okay, to break down emulsion, to break down emulsion. Okay, and reduce viscosity, and temperature rise will be like 75 degree to 80 degree centigrade. Okay, you have to convert it in Fahrenheit. 75 to 8 degree. This is thumb rule, like about 75 to 80 degree centigrade temperature is increasing, but the temperature increase also will be differing based on your viscosity, gravity, what type of fluid you are using. Based on that, this temperature rise will be controlled. Okay, and heater treater works basically this degassing also they will do. Okay, when it is increasing temperature, so low density or low molecular weight or short chain hydrocarbons will be evaporated quickly, so it will be separating. Okay, so degassing will be possible, and heating you are giving like 75 to 80 degree depending on the viscosity of crude. Okay, the temperature you are applying depending on viscosity, because how much viscosity already there and how much you want to change. Okay, so depending on that you are using. Sometimes you are using natural or forced draft burner. Later we will discuss what is the natural draft and forced draft burner. Okay, and coalescing will be easier if you have heated. Okay, because viscosity change, and if you are using heater treater or other method, then coalescing will be easier. So in many cases, if you are using heater treater and electrostatic precipitator, electrostatic separation system, so in that case heat requirement will be lower actually, because you are heating, viscosity change, now you are using electric field, so both will work together and it will be reducing your retention time in the separator. Okay. So normally in both cases horizontal and vertical, we are both cases you are using heater treater. Okay. Okay. Now we will start with vertical separator. So how it is looking like? I'll draw vertical separator like this. Okay. So in exam I can give like draw vertical, because if it is online exam then I cannot give, but if it is paper pen based exam, so in that case I can ask, okay, draw vertical separator and show the flow path, draw different fitting inside and outside. Okay, but it is online exam, so in that case what I'll do, I'll give one separator maybe, then I'll put ABCD and mark it which one correctly fitted. Maybe I'll give wrongly fitted your downcomer or gas outlet, maybe some wrong place I'll put, and I'll ask you identify which is wrong. Okay, so if you have practiced drawing this one and if you know the different component where it is fitted and how it is fitted, so in that case you can get good marks. But if you are not sure where my spreader will be there, where my that fire tube will be located, so in that case if I give wrongly some things, you will not be able to identify. Okay, so you should practice how to what are the things are there inside separator. Okay, so it will have one downcomer. Okay, downcomer will be coming like this. Okay, and it is this, and there will be one chimney. Okay, and you know already there will be one mist extractor. This is gas house, so this is called mist extractor or demister, mist extractor. Okay, and there will be inlet port, and inlet will be passing through diverter, right? Inlet diverter will be there, so this is called diverter, inlet diverter or diverter, fine. And this is called downcomer, and this is chimney. And downcomer, when fluid is coming, it will come from top and there will be one spreader. Okay, the spreader means slowly you are spreading liquid or gas, you are not creating turbulence. Okay, so slowly you are passing the water zone, and where this spreader will be located, spreader will be located just below the water and oil interface area. Okay, let's see, this is my water. Okay, just below the water oil interface. Okay, now I have heater treater, right? So heater treater, it will, one pipe will come, here like this, it will be like this. Okay, so this pipe is going and coming out, so it is exchanging heat there. Okay, so fire tube, this is fire tube, and there will be oil level here, and there will be one coalescing section. We are assuming this is coalescing section. The here maximum particle will be coalescing and water droplet will be going down or oil droplet will be going up. Okay, this area, coalescing section. Okay, this is oil out, we can put wear or something. Okay, and water you can take out, and there will be drain valve. So sand and other thing getting deposited, so the drain valve will be there, so you can remove the sand there. Okay, and here one thing, this okay, we'll see this one later. Okay, so spreader should be below the water and oil interface, and there oil and water mixture will be heated up using your fire tube. Okay, so fire tube will be exchanging heat and lots of heat will be going to your mixture, and when mixture is heated up, your oil viscosity will change. When viscosity changed, so oil particle will try to move up and it will not hold water particle tightly. So water particle will try to fall down. Okay, when water particle falling down, so it will go to water outlet line and you are getting water out. Okay, so this is your vertical separator. And if you have any other fitting, so later we will discuss what are the different other fittings possible. Okay, this is the simplest one. Now it is four more major section. Gas separation section, you can see this one actually gas, free gas will be going out. Okay, then this is coalescing section, this is oil, this is coalescing section. So more emulsion will be there in coalescing section. Oil section means less emulsion. Okay, so actually it is water particle almost removed there, and water particle removed, oil you are taking out, and at the nearby bottom water is free from oil, you can say. So this will be free water area. Okay, so free water knockout area actually, this bottom portion, and top portion is free gas out. Okay, gas separation is happening at the top portion, and heating and water wash happening where fire tube is there. Okay, fire tube is there, it is heating and it is nearby water, so oil particle will be washed and it will be moving up. Okay, and coalescing and settling section is there. So where lots of particle will be colliding, oil particle will be colliding, water particle will be colliding, and settling will be happening. Okay, so gas separator section is very smaller if it is placed downstream of a separator. So already upstream separator is there, and already your pressure is going down. Okay, then you are moving to this heater treater. So in that case, gas amount is lower. So gas settling section will be lower. Okay, that is size of that area. Liquid flow through the downcomer to the base of a heater of the treater, which serves as a FWKO. Okay, free water knockout will be like below of your spreader. So this is called free water knockout. So free water is there, so it will be going out. Okay, if the treater is located downstream of a FWKO of a three-phase separator, so in that case free water already lower. Okay, so the water section will be lower, the size will be smaller. Okay, if total well to steam to be treated, water retention time 3 to 5 minutes will be okay. Okay, to allow free water settle out to minimize fuel gas in heater. Okay, fuel gas means like fire tube is there, fire tube needs some energy to heat, right? So that to reduce that one, so water heating time reduced. Okay, if you are heating water for longer time, so it will take more heat. So your fuel to heat this system will be more. Okay, so to reduce fuel requirement, you are giving 3 to 5 minutes retention time and remove water. Okay, then again when you are removing, actually continuous inlet flow is coming out and water retaining 3 to 5 minutes. Fine. Okay, now you have one coalescing section. So coalescing section also will be different designs. There will be one design is that like you have downcomer. Okay, just this is my separator, let's just assume, and I have downcomer. Okay, and I will have one plate, I will have another plate like this. Okay, this is my downcomer, fluid is coming. Okay, maybe there will be one spreader. Okay, so downcomer is there, so fluid is flowing, coming down like this. Okay, and it will be getting spread like this. Okay, so fluid will be moving like this and this and this. Maybe another different plates will be there in coalescing section. So in coalescing section, fluid is moving up or down, so it will be flowing like this. Slowly it will be flowing, and when it is flowing, actually it will be creating more collision. So when collision is more, particle size will be increasing. Okay, so you are creating one calm zone. Again you are allowing fluid to flow with creating actually laminar flow, not turbulent flow. If you are creating turbulent flow, again maybe particle will be broken or it will get separated. So you are trying to create laminar flow, and slowly particle will be moving and it will be getting more collision. When collision is there, it will particle be increasing in diameter. So diameter increasing means Vt formula, you can remember, Vt proportional dm square, particle diameter square. So diameter increased means settlement rate will be increasing or separation rate will be increasing. Okay, so that will be there in your coalescing section. So baffles, this is called baffles. Okay, baffles with lots of pores or holes. Okay, so baffles installed in the coalition section cause the emulsion to flow back and forth. Okay, and particle collision will be higher and separation rate will be better. Okay, heating removes more gas. Heated clean oil preheats incoming cooler. So now this oil whatever you are getting out, so that will be having higher temperature also. So that temperature again used for heating inlet flow, so that you are recovering some amount of heat. Okay, because if you are not recovering, you are giving some energy, so there is energy loss. So monetary loss is there. So the designers will do like this: your oil already heated, water already heated. So can I use that oil water, or there will be heat in the source of your IC engines or other engine systems. So that heat can I use, so that some energy can be saved. Okay, so just to optimize the whole surface production system, so low energy consumption and higher performance. Okay, separated water flows out through the water leg. Okay, later I will discuss water leg. And vein type mist extractor, normally vein type mist extractor will be there. So different types of mist extractor I discussed already, I think. So vein type mist extractor you can use there in heater-treater system. Okay. Okay. So now if we have larger amount of gas, so actually when you are using heater-treater should be having lower amount of gas. Okay. If you have larger amount of gas and you are heating, so large amount of gas bubbles will be coming out. So when bubbles coming, it will get lots of turbulence. So it will be hindering your separation actually. Okay, larger amount of gas separated, it will be turbulence will be increasing and coalescence will be a problem. Okay, small gas bubbles have attraction for water. Okay, for surface active matrix material, so it will be creating small bubbles, and surface active agent will not allow to collide. Okay, so that will be hindering your separation process. Okay, standard vertical separator sizing will be like 20 to 27 feet. Okay, this is one thumb rule, standard vertical separator size. Standard vertical heater treater. Okay, and if you assume 3 to 4 cylinders ratio, so just 1/3 or 1/4 you can make, so 5 feet or 6 feet around will be your diameter.